Hello, and welcome to TutorTube, where the Learning Center's lead tutors help you understand challenging course concepts with easy-to-understand videos. My name is Calvin Garcia, lead tutor for computer science. In today's video, we will explore pointers. Sometimes programs can get very large, especially when we declare a bunch of variables in our functions, our structs, and our classes. Pointers can help minimize the memory being used by our program, while also allowing for dynamic allocation of memory. A variable's address is the location a variable's value is stored. What does it have to do with pointers? Well, a pointer is a variable, but addresses are the value it holds. Wikipedia's hyperlinks that lead to other wiki articles are pointers to those articles. They use the address of the pages to point to their location. A pointer is declared using the same data type as variables. To show the data type is a pointer, we add an asterisk. A particular pointer type can only store addresses of the same value type. This means, for example, int pointers can only store int addresses. Pointers don't need to be assigned variable addresses. We can also allocate the memory they use ourselves as programmers. A program allocates the memory a pointer uses during runtime. If we have an int pointer, ptr, we can allocate memory to the pointer using the C function malloc, which is used ptr is equal to open parenthesis int asterisk close parenthesis. This signifies that we're returning a int pointer. Malloc open parenthesis the size of our type multiplied by the amount of memory we want to use. We can then assign value to the pointer by dereferencing it using the asterisk. If we were to output the pointer, what would be displayed? What if we output the dereferenced pointer? Using the concept of dereferencing, we can perform arithmetic with our pointer. In this case, we will add 10 to our pointer's stored value. If we again output the pointer, what will we see? What if we dereference it? In both cases, we find that outputting the pointer displays an address. This address remains the same even after performing arithmetic to our pointer's value, which does change. What if we instead wanted to create an array? We could use the same malloc function, but instead we'll use calloc. Which is used the same way as malloc, ptr, then our int pointer return, then calloc, followed by the amount of memory we want to allocate. Then the size of our type, in this case int. The main difference between malloc and calloc is the way they initialize memory. Malloc leaves the values inside the memory as they are, and calloc initializes the bits to 0. There are many ways to dereference array pointers. One method is using array notation, which uses the square brackets to denote the index of the array. This makes sense since we allocated an array of memory. Another method is using the asterisk as before and adding the index to the initial address stored in the pointer. As in asterisk, open parenthesis, PTR plus I, close parenthesis. This is because the memory is allocated in series. Therefore, we can add to the address and find the next address of our array. To show this is the case, we can output PTR plus I and ampersand PTR I side by side. We know that referencing a variable gives its address, so the address ampersand PTR I should match PTR plus I, which is our initial address plus the index. In C, we can resize the memory allocated using realloc, as in PTR is equal to int pointer return realloc PTR followed by the amount of memory we want to allocate times the size of our type, in this case, int. When we allocate the memory ourselves within our program, the compiler and the computer don't know when to stop reserving the memory, so we must tell the computer. We do this by freeing the pointer within our program whenever we are done using it. In our previous example program, I did not use the free function to free our pointer, but it's still compiled. Again, the compiler does not know when we are allocating memory because it is done during runtime. It is good practice to always free pointers to avoid memory leaks. In C, this is done using the free function, as in free PTR. Though we did not talk about C++ allocation methods, it is important to note we cannot allocate pointers by combining C and C++ methods. That is, if we allocate using new, we cannot use realloc to resize the memory allocated. This is also true for delete and free. If a pointer was allocated using malloc, we cannot use delete. If a pointer was allocated using new, we cannot use free. Remember, new goes with delete and malloc/calloc go with free. Thank you for watching TutorTube. I hope you enjoyed this video. Please subscribe to our channel for more exciting videos. Check out the links in the description below for more information on the Learning Center and follow us on social media. See you next time.